Hi, so we're studying chapter 2, organizing data, and this video is about section 2.2, organizing qualitative data. All right, so I'm going to share my screen and I'm going to ask you to look hard at, there's going to be some information. They're going to be blood types. I want you to look hard at those blood types and then I'm going to take it down. I'm going to ask you a question. So hold on one second while I share. Okay, those are the blood types. And my question is, which blood type was most common? I asked you to put $10 down on the table. Would you have an answer? All right, just a question. Are you sure? So myself, I wasn't really sure because they weren't really easy for me to catch that information from. So I'm going to introduce the first statistic that we have in this class. And the statistic is to take that data that I just showed you on blood types and present it in a format that makes it easier for you to answer that question. All right, so hold on one moment and I will bring the screen. I'm going to share my screen again and remember the question. Which blood type is most prevalent? Okay, so maybe you have an answer. Maybe you have at least a better feel of it. Maybe you'd be more willing to put $10 on the table and guess or bet, right? So maybe there's a higher level of certainty that you have. And so what our job is when we're managing and we're presenting summaries of data is to try to figure out if there's a story behind the data and how to best tell that story. Okay, so I'm not going to tell you what the answer is, but I'm going to show you one more summary of this data. All right, so hold on one second. I'm going to adjust my screen. Same data, but this time it's going to be presented in a different format. Okay, that's it. What's the most common blood type? So we saw in the notes that I just presented that, and I'll just bring that back up. That the most common blood type is O, right? 44% of the patients in that data set, represented in that data set, have a blood type O. 35.3 have the blood type A, 12.7 have a blood type of B, and 8% have a blood type of AB. So how did I come up with those numbers? Well, what we see is that there's a total of, down here we see a total of 150. So a total of 150 blood types or patients with blood types represented in our data set. There are 66 of those patients had the blood type O. And so to calculate the percentage of the patients with blood type O, we took 66 and divided it by 150. That gave us 0.44 and then multiplied by 100%. So often in this class, I like to give examples that make sense before I give a whole bunch of formulas, because I find that people can actually, the ideas are maybe even easier to understand before you put out a bunch of formulas. So we're also going to, so let me just kind of translate that information here and use a little terminology as I do this. So we have blood type, frequency, and what we're calling here relative frequency. And we have A, B, B, and O. And these are the counts or the frequencies. So if you go back to that original data, this stuff is all in the notes on Blackboard. If you go back to the original data, you'll catch, you'll be able to count, and you count it, or if you go to the sorted version of the data, it might be easier to count. But that's, I had a software system do the counting for me. So this is where these numbers come from. And then, so these are called relative frequencies. The other word I used to describe them was percentages. So these are the percentages. And if I add up all the percentages, what do you think that sum's going to be? 100%. All of the patients are represented here. We had a total of 150 people people represented in that data set. Okay, so this is a table. You might be asked to produce a frequency distribution, and that would be the first two columns. The relative frequency distribution is the first and the third, and often I'll ask for both, and you can put them together into the same table like that. We can also produce a visual, a graphic, which displays this information. So the graphic is going to be called a bar chart. All right. And in any graph, we have axes, right? And so the horizontal axis here is going to take on blood type. And we have, I'm listing them as I have them in the notes. And really why they're listed this way is just because this is the alphabetical listing, and that's what the software that I use to produce the graph in the notes does by default. But they don't mean anything because, as we kind of talked about last class, blood type A, the type itself is not bigger or smaller than blood type B. So certainly alphabetically, A comes before B, but those are just labels, and they really don't have something to do with the size. So, and let's see. So I'm going to do a bar chart. This bar chart is going to be a frequency bar chart. So we want to set up the vertical axis so that these numbers can be easily displayed on that axis. And so we see that the numbers go from 12 to 66. We want to make sure we include the 0 when we're doing frequency bar charts or relative frequency bar charts. And some of the other graphical techniques that we use, we'll have to make sure that we include the 0. Or I'll show you at the end of the chapter some variations on how to handle it if that doesn't seem like a good idea. So that's going to go from 0 to, let's say, 60. You want to round it up to some pretty number. You want to pretty it up. Okay, and so I chose those values that make it a little easier for us to work with. Bar charts have these bars, and their bar charts are for qualitative data, right? So we're going to only use this. We're not going to use this for quantitative data. For quantitative data, we'll use a similar graphical technique called histogram. But for qualitative data only. And when it's qualitative data, we're going to draw some bars here, and we're going to leave gaps in the bars. So there are 53 patients that have a blood type of A. So I'm going to go up to about 53. Right? And I'm going to leave a space here, and there's 12. So maybe a little bit like that. B is 19. And O is 66. Ooh, I didn't make my axis big enough, so let's go ahead and add another tick mark up there at 70 and bring it up to 66. So what's important here is that the bars do not touch. And the reason the bars don't touch is for the eye to move away from the feeling that A is somehow next to AB, that AB is somehow bigger than A, that this is a number line. All those things, we don't want to portray that in a bar chart for qualitative data. So the space here is to help us understand that this is not a number line, okay? If I ask you to produce a frequency bar chart, this is what I expect. Grading scheme would be, say if it was 10 points, you would get 3 points for the axes, 3 points for the bars to be about the right height, and 3 points for that space. So that this would be our full credit. Even though it's a little messy, I would still get full credit. You would still get full credit. Okay. So there, I do want to go through the formulas a little bit, and then we'll have a class activity to do when we get to class. All right. So there are some definitions. Why don't I just pull them up here on the notes, and then I'll share the screen once I get the notes where I want them to be. Okay, all right. So this is a pie chart, and on a pie chart, the slice of the pie is determined by this relative frequency. And I'm not going to ask you to draw pie charts in class on a quiz or in a test or something like that, but I want you to, be able to read that, and you should have some practice with my stat lab on that, just to be able to read it. So we note that in a pie chart, the blood type that is most common has the biggest piece of pie. So it's this purple one here. Okay. And and here are the formal definitions, which I said I was saving until we had more of a, fun playing in the data first. So the frequency table is just a table that lists the number of occurrences for each category in the data. And the relative frequency table is the proportion or percent of observations within a category. So the relative frequency for blood type A was the frequency of blood type A, 53, divided by the sum of all the frequencies, which was 150. So we have 35.3%, which is 53 over 150. And let's go ahead and see what else we have to go through in terms of formal definitions. So we have the bar graph or the bar chart, which is constructed by labeling each category of data on the horizontal axis, right? And the frequency or relative frequency, depending on which one you're graphing, on the vertical axis. Okay, so the widths of these rectangles or bars are about the same. I guess the one thing I do want to cover, and I don't think it's in the notes here, is I also want to draw a relative frequency bar chart over here. And so just so we can see how the frequency bar chart and the relative frequency bar charts kind of look and how they're similar and how they're different. And the only other thing I want to do is while we start to talk about this relative frequency bar chart, our bar graph, I want to go over at least one calculation. So we'll start with that. So we have the relative frequency, just in case people are a little confused with the percentages and the decimals and the division and all, just to go through one. The relative frequency of A is going to be 53 divided by 150. So calculators out now. That would be helpful if you could work along with me. I'm going to grab my calculator. And I'm getting 0.35333. And it keeps going with the threes. Okay, I want to transition that I want to translate that or transform that to a percent. When you take a number from decimal to percent, you move the decimal point over 2 places to the right and add a percent sign. So this is equal to 35.33%. And I say equal, but clearly there's this long tail, which we're kind of not getting in the middle of, we're rounding it, right? So 35.33, so you do the division, and that gives you your decimal, move the decimal place 2 to the right and add percent. And that's how these numbers come from the formula that we just saw in the notes. Okay, so let's go ahead and look at a relative frequency bar chart or bar graph. All right, and so we're going to do the same thing as we did over here. Our horizontal axis is going to take on the values of the categories. And the vertical axis has to work for these relative frequencies. We could use 100, but what's going to happen is we're going to end up squashing the graph down here. We don't really need to have the graph go up to 100. We want to look at the highest frequency, relative frequency, which is this 44%. And we want to make sure that everything looks good up to that. 44% rounded up to something pretty, it looks like 50% to me. So we're going to go ahead and take this highest point at 50, and then in the middle, we have 0, and that's 5, 10. These are all percents. I'm not going to fill in all of them. I'll fill in. That's enough. Okay, so this is 45%. 40%. All right, so you get it. 35% for A, so 25, 30, 35. So the 35.3, a little bit above the 35 mark. That's the relative frequency bar. Okay, AB is 8%, so somewhere between 5 and 10. And B has 12.7%. So 12.7%, it's somewhere between 10 and 15. So I got it over there. And finally, O has the 44%. So I'm going to take that up here. Whoop. And again, you don't have to be really neat. You have to like try to make it clear. Clear enough, neat when it matters. That's my motto in life in general. Okay, so here's our relative frequency bar chart. And here's our frequency bar chart. Let's go ahead and label this as blood type as well. And I could say relative frequency, or you could call it percent over here. This other chart here ought to have count or frequency. So you know, the labels are always, the axes are always labeled. What do you notice about the chart on the left and the chart on the right? there's ways in which they look similar, like, for example, their shape, right? So more or less, they're about the same. Particularly if I made this a little more accurate, this was supposed to be 66, so maybe it was only supposed to come up to there. So they have the same shape because the transformation that brought frequency to relative frequency was a linear transformation, and it just rescaled the numbers by dividing by 150 and then multiplying back up by 100%. So they end up having the same shape when you go from frequency to relative frequency, but the value, what changes is the vertical axis. All right. So there is some fun that we're going to have in class, collecting class data, moving forward with that. So I'll see you then.